Let's look at how do planes generate lift. As we know, a plane consists of a body with two wings, as so. Now, what creates this lift is actually the two wings that is attached to the body. If we look at the cross-sectional side view of the wing, it is shaped somehow like that, where the top is circular and tailed at the bottom, and the bottom is flat. Now, as the wing moves forward, the wind is deflected and moves in two directions. Above the wing, where it moves the same path as the shape of the wing, and the bottom moves as so. Now, if we look at the top, the particles of the wind have to travel a larger distance. So we have a larger distance here due to the shape of the wing, and since this is flat, we get a shorter distance, as so. Now, because the particles split at this point, they have to get at this point at the same time. And that means since this has to travel a longer path, it has to travel with a higher velocity and speed. And vice versa for the other one, which will be shorter speed at the bottom. And because of that, Bernoulli's principle states that an increase in the speed of a fluid, there's a decrease in pressure, and vice versa. So if you look at this point right here, it's a higher velocity, so there is lower pressure, and vice versa for the bottom. So since there is lower pressure here exerting on the wing and much higher pressure here, what's going to happen is we're going to get lift, and that's how the plane's going to go up in that direction. But matter of fact, this is the wrong concept. Some of the concept in this scenario is correct, such as the change in pressure will create lift, and also that high velocity, and was stated with the Bernoulli's principle, that higher velocity creates lower pressure. But what's wrong is that the point here doesn't have to, as the wind moves this way, it doesn't have to get here at the same time. Matter of fact, it doesn't get there at the same time. So what really is happening is we have to include Newton's third law of motion. If we draw the wing one more time, we can see now as the wind is moving this way, we can ask ourselves, why is the path of the particles staying onto the surface of it, as seen here? And this is because as we go up in layers, we can see that at the top we get atmospheric pressure, and that, if we look at one path, the top of the pressure here, pressure at the top, is higher than the pressure at the bottom, which creates the wind flow to stay stuck on the surface. Now, Newton's third law says if you push something with a certain magnitude, it will push the other way in the same magnitude. So, if we see here, it's pushing the other way, deflected the other way direction as the plane is moving, and downwards, as so. And then that forces the bottom to deflect as well. Because it's deflecting down, the plane wing is going to deflect the other way due to Newton's third law of motion. And because of the change in pressure that this created, and Newton's third law is going to create lift with the same magnitude that the pressure is pushing down. Now, as the plane ascends upwards with a higher angle, the higher the angle, the bigger the magnitude of pressure and the higher the lift and force to push the plane up will be. And this is all due to Newton's third law and Bernoulli's principle.